Okay, so 5, 6 is radical functions, and specifically we're going to be talking about the graphs of them and what that means. So we're going to talk about radicals. So when we talk about the square root of a number, there's some things that we know. Let's talk about the square root of x, meaning that x could be any number that I want to put in there. But there's certain numbers that I shouldn't put in for x. Like, what should I not put in there? Well, I can put in 1. The square root of 1, I know.
0.
I know the square root of 0. It's 0.
3.
The square root of 3 is a number that I could figure out. I don't know what it is. But there are certain numbers that would not be appropriate to put underneath there. Negatives. So notice that, like, when we look at our first graph here, we're going to look at the graph of the square root of x. This is the graph of the square root of x. And notice that it does not go any further to the left than right here at 0. Why? Because x, these are the x values, right? Here are all the x values. It's not allowed to be any of these numbers that are in the negative. You can't do that. It's not going to exist there. So we call this our parent function. And we call it a parent because it's like the most basic version. So this is called a parent function. If you look back in the back of the classroom, the picture of the boat with the dolphin there, this represents like the square root function like there. Like all of these are a different function. And that one is kind of talking about how like the sonar that dolphins use to communicate, or even the sonar in boats that communicate, like find fish, find other things in the water, all of those things are based on the square root function as to how they work. And we'll learn more about it. But this is called a parent function, meaning that we are going to mess with this. We are going to modify it in some ways, but this one hasn't been touched. It's a very basic version. It's the parent function, the square root of x. And it always kind of looks just like this. Now we're going to mess with it a little bit. But if you're wondering why it doesn't go any further to the left, well then it's because, bless you, because we can't plug negative numbers in there. If we plug a negative number in, then we don't know how to do the square root of it. And if you notice, there's nothing below the y-axis either. That's because when we take the square root of a number, we shouldn't be getting negative numbers as the answers. That's why all the y's are positive and all the x's are positive. So we're kind of limited to this first area here. Our graph is kind of stuck. The parent function is stuck in this area right here. This is called quadrant 1. Like we use the Roman numeral 1 there. So this is like the first quadrant because all the x's are positive and all the y's are positive there. So this is the parent function. Now we're going to talk a little bit about domain and range, and you guys talked about that in Algebra 1 as well. So when we talk about domain, one of the things that you guys are going to have to answer is what are the domains and the ranges of these things? But it's actually way easy to see when you graph it. When we talk about domain, what we're really asking you for in plain English is what can you use for x? That's like the English translation of when we say domain. Like, what are the possible numbers that I can use for x? And in this case, am I allowed to use negative numbers? No. So what is the smallest number that I could possibly put into this function?
0.
0, right? I'm allowed to use 0. I can take the square root of 0. Anything less than 0 is not allowed. And this would go all the way up to what? Like, what number could I put in? Like, what's the biggest number I could put in? Infinity. Like we can go all the way up forever. As long as they're positive numbers, we're okay. Now, here's the thing. Infinity is not a number. It just represents that the numbers keep going on, so we can't include that number. So if you remember back to Algebra 1, this bracket right here means that this is included in the answer. Like you can definitely use 0. This is not included, meaning like you can't plug in infinity because infinity is not a number. So when we're talking about the domain, if you notice, look, it starts right here at 0, and it keeps going on forever to the right, which matches exactly what we said right here. It starts at 0 and goes forever to the right. So if domain measures the x's, so domain is all about x's. Domain is about the x's. Well then, the next thing we're going to talk about is the range. So ranges are all about y. Now, if you look at this, the y, the lowest, when we talk about y's go up and down. So when I say what is the furthest down it goes, it never goes below this line. Would you agree that that's like the floor? When I think of range, I think of floor to ceiling. Like what's the lowest it goes, like on the y, and then what's the highest it goes. So I would say for the range, the lowest it goes is what? What does that look like? That's that number all the way down here. 0. And it goes up and up and up and up. And even though it's not going up super fast, it looks like it keeps going up forever. So what would the range be?
Pardon interruption.
So it keeps going up forever and ever and ever. So the range is also from 0 to infinity. And that's where we get this information right there. Like you're going to be asked about certain things and what the domain and range are. And it's really super easy for this because we're just looking at it, we go, oh, okay, well, we know that we can't use negative numbers. Like when you think about the square root, we can't use negative numbers. And we know that the domain are from 0 all the way up to infinity. And so is the range, because it's not going to go below 0. Because I can't get a negative number out of a square root. I can't do the square root of a number and get a negative. Like, that's not going to happen. Are we okay with that? Because I think that's kind of like one of the hardest parts there. Everything after that, like if you feel like you're with me so far, I feel like that's kind of the hardest part. Just understanding domain and range. Because a lot of times people didn't really fully understand it when they did it in Algebra 1. But that's all it means. Is that what are the possible x's and what are the possible y's? And it's super easy to look at when you see a graph. You go, oh, wait, I see. How far does it go to the left? Well, it stops at 0. How far does it go to the right? It goes forever to the right. How far does it go down? Well, I just look at the floor and ceiling there. It only goes down to 0. And how far does it go up? Up forever. Yes, ma'am.
So are we going to end up solving for x and then later solving for y?
Well, we've already solved. Well, it's not solving for. We've already solved for x in like the last test. Like we solved for x already. We're not, when you do domain and range, we're just saying what are the possibilities that it could be. Like notice that all of these are little points, right? They're just a whole bunch of little dots that somebody played connect the dot. There's x and y values, right? For every x, there's a y. For every x, there's a y. And what it does is it gives you an idea of what this graph looks like. And it would look like this, and it would keep going on forever and ever, keep going up and up and up like that. So it gives us an idea of just what is possible for x and what is possible for y. Some things are not always possible. Now, when we get to the cube root, we can take negative numbers because if you think about it, we can do this, right? We did this on the test. The cube root of -8, that's possible. Because I know a negative times a negative times a negative, that can be a negative number. And this would just be -2. So I am allowed negative numbers when this is an odd number. So if that's a 3 or a 5, I can use negatives then, but not when I'm taking the square root or the fourth root. That's not going to be possible. So if you notice the difference between the graphs, look at the graphs. The right-hand side, the part in quadrant 1 up here, is exactly the same. But now when we do the cube root, we have that same thing mirrored down in quadrant 3. So here's quadrant 1, here's quadrant 2. Just so you know, I'm going to refer to these a lot by quadrants. So if you weren't familiar with them, with their names, that's quadrant 3. And this is quadrant 4. And often in math books and other math teachers will use the Roman numerals, so you'll see them as I, or IV. That's the Roman numerals of them. And so you see it's mirrored over here. And this is what that graph would look like. Now, notice the domain and range. Let's look at this graph. When I'm talking domain, if I ask you about the domain of this, you're just going to look at the graph and I go, just think about left and right. Excuse me, how far does this go to the left and to the right? How far does it go to the left? It goes infinitely to the left. So we call this negative infinity. It goes forever infinitely in the negative direction. Now I can include that. That's why I used a parenthesis, not a bracket. And it goes all the way up to, what's the highest number that this goes to when I'm talking about domain? Infinity. It goes forever to the right as well. Because remember, we're talking about x's, and x's go left to right. So I'm looking at how far did it go to the left, how far does it go to the right? Bless you. So the domain is from negative infinity to infinity, or you might just see it written as all real numbers, meaning it can be anything. We have every single number there left to right. We're allowed anything we want for x's. That's totally okay. And now we're going to do the same thing for range. We're going to determine what the range is. And now we need to determine how far does it go up and how far does it go down. We always go like left to right and down to up. So what's the smallest value that this could be, like the lowest value?
0.
So this never goes below. Here's 0. When we talk about y's, here's 0. It never goes below that line? Yeah, it goes all the way down to negative infinity. It's going to keep going down and down and down and down and down forever So we've got from negative infinity, and how high up does it go? To positive infinity. It keeps going up and up and up. Now it's going up slowly, I'll admit. It's going up, like first it goes up really fast, and then it kind of balances out that it doesn't go up as quickly. But it's still going up, just really slowly. It's like imagine you're trying to run up a set of stairs, right? Like if you had to run up like 10 flights of stairs and somebody was timing you, you're probably really fast on the first couple sets of stairs, like you're pretty fast. But then you start to feel it. And then you're like, the last 2 sets of stairs are probably your slowest because you're starting to really wear down. So these are both called the parent functions. They're just, one is the cube root function and one is the square root function. So that's the two that you need to know, is that just all you need to know is that this is the parent function for the square root of x. That's what it looks like. If you look back there at the poster again of the boats, I don't know if you can see it, at the very bottom it says f of x is equal to x squared. It's that same kind of like picture there. Like it's doing that same sort of like arc coming off of there. Now the cube root function looks like this. But we're going to mess with that. We're going to do some things to it, and that's going to change where this is located. But you're going to be able to recognize it very quickly. Okay, so let's do some graphing. It says graph the function, state the domain and range. So it said graph it. Now here's what we can't do. I already know what this looks like. I already know from seeing it up there that it looks like this. So here's what you cannot do. Do not do this because I would totally take off about 1 billion points from your homework. Don't just go, it looks like this. There's no way, because it said graph it, which means there should be points involved in there. So here's what we're going to do. We're going to pick some values for x and y, and the x values are already there. So let's do this. Let's do them one by one, starting with -1. Let's take the square root of -1. What is the square root of -1? We can't do it. There's no solution. So we can't do this. I'm just going to put an x there. We won't have coordinates. You can't do that. It's not going to be it won't be on our graph because we can't do that. But what if I plugged in 0? If I took the square root of 0, what would I get? 0. I'd get 0. And then what would my coordinates be? 0, 0. Okay, now I'm going to try 1. I'm going to do the square root of 1. And what's the square root of 1? 1. So what are my coordinates? 1, 1. Now notice that I skipped 2. Why do you think that I would skip 2 and go all the way up to 4? Think for a minute, like there's a logical reason. Why did he skip 2 and 3 go all the way up to 4? Right, because we don't know the square root of 2 and we don't know the square root of 3, but we do know the square root of 4. What is the square root of 4? It's 2. So stick with numbers, like when you're graphing, that are easy for you. Like don't make it hard on yourself. You're not going to have a calculator, so you might be like, well, I don't know what the square root of 3 is. Okay, well then why did you use 3? Let's do the square root of 9. The square root of 9 is what? Okay, so we get the coordinates 9, 3. Now I'm going to graph those. So here is 0, 0. Here is 1, 1. Here is 1, 2, 3, 4, 4, 2. 4 to the right and 2 up. And then 9 to the right. 8, 9, 1, 2, 3. And notice that my graph takes shape. And that's what I'm looking for there, are those points. So I use the x values to determine. Now, it also said state the domain and range. Now, knowing that I've got a picture there, that certainly helps. I can go, okay, now I can figure out the domain and range. We already know that it couldn't go in the negatives, so let's talk about the domain again. What was the domain of this? The x's. What's possible for x? Okay, from 0 to what? To infinity. It can go up to infinity. Oh, sorry, I put this should be a bracket because we are allowed to take the square root of 0. And what about the range? 0 to infinity. Just like we had before, the range and domain didn't change. It's still the exact same graph that we did. All we have now are the actual points that we used. So like when I think of, this is how I think of it, like when I think of domain, I think of that this is all about my x values. So here's my x-axis right here. And I look at it and I go, does this go forever? Does like the black part, the graph, does it go forever to the left?
To the right.
It goes forever to the right. So that's getting bigger, right? So when we talk about domain, I know that how big does it get? It gets up to infinity. But then let's talk about how small does it get, going the other direction.
0 doesn't.
It stops at 0, right? It's going like this. It keeps going left, 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 left. And where does it stop over here? It stops at 0. When we're talking about left and right, it goes forever to the right, but it stops right here at 0. So that's where we got the domain. Oh, sorry, that's including 0. And the range is kind of similar. Let me just get rid of some of this. Now the range is like up and down. So I'm looking this way and I go, what is the lowest that this goes? Like where is the lowest point on this graph? Like imagine that this is like, you're traveling along this graph. You're like, doot, 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 and it's going up and up and up and up. The highest point is what? How high up does it go?
Infinity.
It goes up to infinity. And what's the lowest point it goes as it comes down? It goes down, 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 down until it gets to what? 0. This line right here, this where it stops right there, is the line y equals 0. It stops at 0. So that's how we get the range. So it's all about up and down and left and right. Like domain is left and right. How far does it go to the left? How far does it go to the right? Now we're going to do a different one. Notice that this is the cube root function, but things have changed here. This is not just the parent function. Like this is this one, except for they added a 4 underneath and a 4 on the outside. That's going to change things. So we need to look. It might change the domain. It might change the range. We're going to interpret that, but we're going to interpret that by finding points. Now, are we allowed to use negative numbers when it comes to the cube root functions? Yes, that's okay. So they want me to try negative 12. So what I'm going to do is this. I'm going to plug in negative 12. So we get 4 times the cube root of negative 12 plus 4. And I'm just going to work this out. Negative 12 plus 4 is negative 8.
You're just plugging in right now.
Yeah, all I'm doing is starting right here. I'm trying to find out that y coordinate. Is that when I put in negative 12, I want to see what I get back. So what is the cube root of negative 8?
Negative 2.
It's negative 2. Meaning negative 2 times negative 2 times negative 2 is negative 8. And then it's 4 times negative 2. What is 4 times negative 2? Good, so I get negative 12, negative 8. So what are my x and y coordinates there for that first one? Negative 12, negative 8. I'm just going to go ahead and put that point on there right now. So it's 12 to the left and 8 down. So 12 to the left and 1, 2, 3, 4, 5, 6, 7, 8 right here. That's 8 down and 12 to the left. I'm going to move on to the next one. They tell me to do negative 5. Now, the numbers that have been chosen there are numbers that, because it makes things that I know the cube root of, like that are going to work out very nicely. So sometimes your x values need to be chosen so that you'll end up at numbers that will work out well. So let's try this. We're going to do 4 times the cube root of, this time I'm going to do negative 5. Negative 5 plus 4, which is 4 times the cube root of negative 1. Well, what's the cube root of negative 1? Negative 1. Negative 1 times negative 1 times negative 1 is negative 1. And then I get 4 times negative 1, which equals? Negative 4. So what are my coordinates for this line? Negative 5, negative 4. So I'm going to go 5 to the left and 4 down. 5 to the left, 1, 2, 3, 4 down. So this graph is going to start taking shape now. Now I already know that it's going to have this kind of like, because it's the cube root function, it's going to look something like this. It's going to somehow be like some sort of like snaky looking type thing. It's going to look somewhat similar to that. So I already have in my mind that what it should look like at the end is something like that. I'm going to plug in negative 4. So we do 4 times the cube root of negative 4 plus 4. And what is negative 4 plus 4?
0.
That's 0. And what is the cube root of 0?
0.
And what is 4 times 0?
0.
0. So we get negative 4, 0. 4 to the left, 0 down, puts us right there. So this is not going to look exactly like our other graph that we had up top, but that shouldn't because we changed some things. We changed, there's a 4 outside, there's a 4 under the radical. I'm expecting that this did some things to it, and we're going to talk about what happened there in just a minute.
Wait, what are the coordinates?
Oh, good, sorry.
-4 and 0.
-4 and 0. We'll do 2 more. We've got 4 times the cube root of -3 plus 4, which would be 4 times the cube root of 1. What's the cube root of 1? 1. And 4 times 1 is? 4. So we get the coordinates -3, 4. And you thought today wasn't going to be fun.
It's easy, it's just a lot of work.
Yeah, I agree. It's not always the most exciting, but this isn't so bad mathematically.
Wait, I just don't understand how do you get the y?
How did I get y? Whatever the answer is, when you plug in x, that's what you get for y.
Oh.
The answer is y. So we go, let's do our last one here. We've got the cube root, so 4 times the cube root of 4 plus 4. 4 plus 4 is 8. What's the cube root of 8? 2. And what's 4 times 2? So we get the coordinates 4, 8, which should be a pretty good representation of what we've got. We've got 4 to the right. Excuse me. 4 to the right and 8 up. 1, 2, 3, 4, 5, 6, 7, 8 up. Now, I know that this is supposed to look like a snake. So what I don't want to do is just make a whole bunch of straight lines. You're going to see that I'm curving it a little bit because it's supposed to look very snaky. So you see how I'm kind of transitioning into it? I'm not trying to just do straight lines. I'm trying to imagine what it would look like if I curved it through there. Very natural curves. I'm not trying to make them like sudden like turns. And we get something that looks like this. So notice the original up there. The original cube root looks like this. But if you were to take that and put a 4 underneath the radical and a 4 outside, your graph would look like this. Now, let's talk about the domain and range of this. Again, just by looking at the picture. Let's talk about the domain of the graph that we just did. How far does it go to the left? Like this one right, this graph right here in black, how far does it go to the left? Is it done going to the left right here?
-3. Oh,
Negative infinity. It's going to continue going to the left forever. Look, it's going to keep doing this forever to the left, correct?
Yeah.
And how far does it go to the right? Infinity. Also infinity. Notice I didn't put brackets on either one of them. Why did I not put brackets on either one of them?
infinity isn't a number.
It's not a number. We can't include it. I can't plug infinity underneath there.
Wait, so do you do the left side first?
You can do whichever side you want first, but understand that the left side goes on the left and the right side goes on the right. So how high up does it go? That goes on the right. How far to the left it goes? That goes on the left. And when you talk about range, it goes bottom top. So the lowest number and the highest number. So let's look at our picture and start just thinking about it. Like, how far down will this graph go? Negative infinity. It's going to keep going down forever too. It keeps going down and down and down while it's going left. How far up does it go? Infinity. So all real numbers for both. All real, all real. There are no restrictions on this. There's no like problems anywhere. It's not like it couldn't be a certain number. It kept going and kept going. Exactly what's going to happen. Everybody bases it like when I start working, they're like, okay, let's mess them up. Okay. All right. So we're going to do 2 more here. Notice that this is the cube root function. This is the parent function. So I already know what this is going to look like. It's like, this is the same one as we started with. It should go right through 0, 0, but we're going to go and find those coordinates. So we have to find the points. We can't just randomly draw these. I'm going to tell you right now, in the homework, if you just start randomly sketching things, I will give you 0 credit for that. It's not just draw a rough sketch. I want points, I want coordinates, I want them to look like it. So there's a precision that's involved in here. Yes, ma'am?
In the homework, are we going to give us the x?
I can't remember how it is in the homework. If not, you're just going to pick things that you know the cube root of. So like, let's say that I had to choose my own numbers. Like, I might start with 1. Like, I could go, like, if I'm going to, I could do the cube root of 1. I know the cube root of 1, right? Because 1 times 1 times 1 is 1. So that's a good number to use. Let's start with these numbers, though. They want the cube root of negative 27. So what times itself 3 times would give me negative 27?
Negative 3.
Negative 3. So we get the coordinates negative 27, comma, negative 3. Now that's going to be way off our graph. That's not even on here.
Negative 9. Oh, wait, no. You're not
So I'm not even going to put this on the graph because negative 27 would be like over here and then like here. So I'm going to just work with some other numbers that I see here. I got 8, negative 8, the cube root of negative 8. That's probably one I can do. What's the cube root of negative 8? This was negative 3. What was the cube root of negative 8? Negative 2. So we get the coordinates negative 8, comma, negative 2. Okay, so I'm going to go 8 to the left and 2 down. 8 to the left, 2 down. Let's do negative 1. Negative 1 isn't listed there, but let's do negative 1. Because negative, like 1's always such an easy number to work with. What is the cube root of negative 1? That's negative 1. So we would get, I'm just going to add this one, sneak that in right there. That's going to be negative 1, negative 1. So I have a coordinate at negative 1, 1 to the left, and 1 down. Now I'm going to put in 0 because they had 0. So what is the cube root of 0? 0. So I get the coordinates 0, 0. So I have a point here. Now since I use negative 1, I'm going to use 1 as well. What is the cube root of 1? What is it? 1. So we get the coordinates 1, 1. You see how 1, 0, they're like great numbers to use? 1, 1. And now we're going to do cube root of 8. What's the cube root of 8? 2. So I'm going to go 8 to the right and 2 up. So notice this one, our graph is going to, now remember, this has to be, because this is the cube root, it's going to be that snake-like look. So I'm going to do this. I got to keep it kind of snake-like.
Why does it have to be snake-like?
Because every cube root function will kind of basically look the same. Like every parabola basically looks the same, but some of them might be thinner, some of them might be wider. This is that same one that has that snake look here. So it always has, on the right, it looks like, my left side's a little off there. Let's try that again. The right side kind of makes, like it goes like a rainbow would. You know, like it goes from 0, 0 and kind of goes like almost like a rainbow, but it never goes down. It just keeps going up. Mine, I should correct that because mine looks like it starts to go down. It really would be going up there. So we should go like that. Keep going up. Okay, so they wanted me to do the domain and range. This should be a lot faster now. What's the domain of this? X's. How far left, how far right? Negative infinity to positive infinity. It goes forever to the left, forever to the right. What's the range? Same thing. Forever up, forever down. This is going to continue going up and down. So all reals and all reals.
So are all of them that are
Snake.
square?
Cube root functions, you mean?
Yeah.
We have a
Are,
question.
hold on one second. So all the cube root functions are going to have the same pattern. Now, in the future, there might be some things that go, wait a minute, like if I do something to it, that might change. But for right now, yes, they're all going to look like that snake. Now, it might be shifted around a bit. It might be moved a little to the left or a little to the right, or it might be a little bit thinner or a little bit wider. They might have those going on. Riley, what's up?
Okay, how do we know about the all real numbers?
Because you notice that if I use all of the numbers going forever to the left and forever to the right, that's all the numbers, right? Like if I go forever to the left and forever to the right on a number line, that's all the numbers. That's all real numbers. All right. The square root of x plus 1. All right, square root of x plus 1. So we get negative 2 plus 1. What does that give me?
-1, so you can't do it.
The square root of negative 1, which is no solution. Okay, so it's no solution, and we're not going to do that. And then we're going to do negative 1. So the square root of negative 1 plus 1, which is? Square root of 0, which is? 0. So we get the coordinates negative 1, 0. If you want, you can put that on there right now. So go 1 to the left and 0 up or down. Now, this is the square root function. So this is going to be just that top part of the snake, not the bottom part. It's going to be just that top part. Now I'm going to do 0. So the square root of 0 plus 1, which is the square root of 1, and the square root of 1 is 1. So I have the coordinates 0, 1. 0 units to the left or right, and 1 unit up. Let's do 3 plus 1, the square root of 3 plus 1, which is the square root of 4. And the square root of 4 is 2. We get those coordinates 3, 2. 3 to the right, 2 up. See how this is starting to take shape? And then we get the square root of 8 plus 1. We jumped all the way up to 8 because 8 plus 1 I know will give me 9. And I know the square root of 9. The square root of 9 is what? 3. So we get the coordinates 8, 3. 8 units to the right. 1, 2, 3 units up. Now notice, this is not the snake one because this is the square root function. It should be just like that one that looks like the top part. And if you notice, I only have the top part there. But something has changed. This looks different than the original one we saw. The other one started at 0. This does not start at 0. Look at how far this goes to the left. It goes a different amount to the left than the original one does. So let's talk about domain. And we have to be really careful here because it does not go forever to the left. Think about it. Like if you want to go to the left, it's going 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 left. It's going to keep going left until it hits a certain number. This number right here, it hits that wall. What number is that? So it goes from -1, and how far does it go to the right? Infinity. So the domain of this one is from -1 to infinity. But notice the only thing that was different about this one and the original one, it was somebody stuck that +1 underneath there. Well, that's what it did, is it messed it up and it changed my domain. So I go, okay, well, the domain's different if I put +1 under there. Now let's do range. Remember, range is up and down. So range is going to be, let's do how far, people seem to do the up part easier. How far up does it go? Infinity. Now, how far down does it go? 0. And here's why 0. Because think about like when it goes down, we're talking about like how far down does it go? And it stops right here. That line is terrible. Let me fix that. Here you go. It stops right there at that line. And that line is y equals 0. That's 0. Above it is 1. Below it is -1. So of course it's 0. So it goes from 0 to infinity. So we know the domain and we know the range. That's something that you are going to have to do is identify the domain and range. So there's a lot here. Like these problems don't look so big at first, but you go, I have to do all the calculations, I have to find the coordinates, I have to graph it, then I have to determine the domain and range. Yes, ma'am?
I don't understand the range, like 0.
Okay, so look at the room, like that we're standing in front of. Like, what would you describe as the lowest point in the room? Like, just look at around the room, and would you say, if I had to say, what's the lowest I can go in this room? The floor, right? The floor is like, I mean, unless you have some sort of digging tools on you, we're not going to be able to get past the floor. Like, if we said, get as low as you can right now, we're all going to lie down on the floor. And if I said, like, what is the highest up that we could possibly go in this room, what would you say?
We stack the chairs.
The vent.
The ceiling, right? Like you could go to the ceiling. Like maybe you could push past the room, but you're no longer in the room then. But the thing is that the highest you could go here is the ceiling. So when we talk about this graph, like it doesn't really, think about this graph. It's going to keep going up and up and up. There's really no ceiling for it. It keeps going up forever. But there is a floor. It never goes below that because we can't it's not going to ever give you a negative number. So the floor, it's kind of like when we do y's, we're considering like how low and how high did it go. It went as low as this line right here, and it went up forever. So it's sometimes you got to think about it like, I always think about, when I think of range, I think floor and ceiling. Where's the floor of this? Where's the floor? Think about it like a room. When I look at it, I go, if that thing were standing, like it's a piece of art or something standing in a room, where's the floor? Find the floor, that's what your low part of your range is. Okay. Now, here's an easy way. So here's why we learn these parent functions. That's why we call them. So we know that the basic ones look like the basic square root function. The basic square root function looks something like this. It started here at 0, 0. and it looks something like that. That's the square root function. We call that the parent square root function. And then we learned that the cube root function looks something like this. It started at 0, 0. It looked the same up here, but then it was like a mirror image down there. That was the cube root function. And now I'm going to tell you what all those little numbers do that mess with it. Like, what do all those things do? What happens when I add a number, when I subtract a number? So notice here, I took this square root and I added 3 to it. Well, when you have a number that is being added to it and it is outside of the radical, notice it is outside of the radical, it's going to move it 3 units up. That's a 3 plus 3, then it goes 3 units up. And notice this is outside of the radical and it's minus 4. That's going to move it 4 units down. But notice these numbers right here are inside the radical, right? They are inside the radical. Did I already tell you my little jail analogy?
No.
Okay, so like those numbers are in jail, right? They're inside, they're in jail. Okay, that negative 2, it's like it's being contained by that radical, right? It's in jail. And negative 2 makes me feel like it wants me to go to the left 2. Like ones that are like inside the radical control left and right. Because notice it's touching the x right there. It controls the left and the right. And it feels like it's telling me to go to the left 2 because it's negative 2. But that number is in jail. And I'm sorry that it made poor life choices and it's in jail, but I'm not going to make the same ones as its recommendation. I'm going to do the opposite of what it says. You see what I mean? It's in jail. That number's in jail. I'm not going to trust its advice. It looks like it's telling me to go to the left 2, so instead I'm going to go 2 units to the right because this isn't it's in jail, right? That negative 2 is in jail. You see what I mean when I say that? It's a number that's being contained, and it's like, hey bro, you should go 2 units to the left. And I'm like, you're in jail. I'm not actually going to follow your advice. What?
Were they in jail?
Money laundering?
Not tax fraud.
No, not yet.
So jail is the negative or that little...
What I mean about jail is notice that this one is in a radical 2. That one's in jail as well. And it looks like he's telling me to go 1 unit to the right. But I'm not going to trust anybody's advice who already made choices that got them in jail. So I'm going to do the opposite and I'm going to go 1 unit left. So numbers that are outside control up and down.
How do you know he's telling you to go to the right?
Because he's not going to the right. I'm going to the left.
But it's positive.
Right.
It would go right.
Right. It's saying plus 1, and plus 1 sounds like move to the right 1, right? And minus 1 sounds like move to the left 1. But if that number's in jail, we are not going to trust it. We're going to do the opposite. So let me just show you an example. Let's say that I have the square root function like this. We already know what that looks like. It looks something like this. But let's say I did this to it. Now I have changed the graph. I have added something to it. That number, that plus 1, is in jail. It's telling me to move to the right 1. And I don't trust it because it made bad life decisions. So instead, I'm going to do what? I'm going to move to the left 1. So the graph of this will actually look exactly the same. But instead of starting at 0, 0, I'm going to move 1 unit to the left. That's what that graph will...
That's what it's telling you not to start at 0, 0?
Yeah, that's all it does. It's just move it 1 to the left. And so when you see something like this, let's say you have this square root function like this. Again, the parent function will look like this. But what if I had the square root function and we had a number outside? The outside numbers control up and down. And this one did not make a bad life decision. It's not in jail, so we can trust it. So what am I going to do?
Start from 0
And go which way?
to the right.
No, remember these outside numbers control up and down.
Oh, so then you go 1 to the left.
Up and down. I can only move up or down.
Because there's an X
You
there.
put it on...
Right, but it's outside. So notice that this was an inside number. It's inside the radical. That's going to be our left and right. So this is left and right, and you should never trust these guys. These guys are always going to try to lead you the wrong direction. So whatever they're telling you to do, you do the opposite. Now this dude's on the outside. He hasn't done anything wrong.
He's still in jail.
He's actually just hanging outside jail. He's like, okay, he's outside. So
He just got out.
But we don't trust him either, right?
why don't you trust him?
Oh, we do trust him.
Well, because he's not in jail, right? We have no reason not to trust him. How about
Why is he
that?
hanging around the jail? That's
Maybe he works there.
He's a prison guard.
He could be a guard.
Oh, yeah.
He's a public defender.
Could be.
Okay, so he's going up.
So he's telling us to go up 1. So you know that 1 that was right here? All I'm going to do is move it up 1 and do the same symbol. That's how it changes the graph. And you can even do both. So let's say I had this, and I had x plus 1 in there, plus 1. That did two things to the graph. What did this do to the graph?
Move it to the left on the.
That moved it left 1. And what did this do to the graph?
Moved it up.
It moved it up 1. So check it out. If I wanted to know what this graph looks like, instead of starting at 0, 0 and go like that, I'm going to start by moving 1 to the left and 1 up. That's 1 unit to the left and 1 unit up. Bam. It's going to look like that. So all of those numbers that look really confusing at first, they all have a purpose. They move it left, they move it right, they move it up, they move it down. And I want to show you one more. Notice that these numbers outside are being multiplied. That's 6 times the square root of x, and 1/2 times the square root of x. Yeah? We all agree with that? Okay. Imagine that I were going to take you, and you're a cartoon character. You're a cartoon character, so this isn't going to be a bloody mess when I do this. You're a cartoon character, and I grab you by your head, and I grab you by your feet, and I'm about to make you 6 times taller. I'm going to stretch you so that you are 6 times taller. But you're a cartoon character, so let's think about what happens to you. Like, you become 6 times taller, but also in cartoons, when somebody becomes 6 times taller, what else happens to their body? They become skinnier. They go inward too. So if you take something and you stretch it 6 times, expect it to become thinner as well. So it's going to get, like, when we have something like this and it's been stretched, it's going to go up 6 times as much, but it's also going to be skinnier as well. So what about 1/2? Well, what if I took your 1/2, what if I took your height and I decided to grab your head, grab your feet, and make you half as tall as you are? Then I'm going to squish you down, right? And so now you are half as tall. What would I expect to do? What happened to your body? You'd get wider, right? Like if I took your head and feet and I squished you down half your height, you would get wider. And that's what we would expect of this graph. So we're going to see that there. And that's what you're going to have to do. The bell's about to ring. I just want to give you those two things.
I don't get it. Are we supposed to make the line thicker?
Well, that's what you should expect to see. You're going to have to graph it. Like you're going to have to still put in the numbers. Like, for example, like check this out. The square root of x times 6. If I plug in 1, then I get this, right? I get the square root of 1 is 1, and then I'm going to multiply times 6. So instead of equaling 1 this time, it's going to be 6 times as big. It's going to be 6. So everything is going to be 6 times as tall as it used to be. So when you're finding your coordinates, you're just going to plug them in as you always did. You're going to find them and plug them in, and you're going to graph it like you always did. But what you should expect is that you should see something that looks 6 times taller. That's what it means. And when you plug them in the 1/2, you're going to get your coordinates. And when you graph it, what should you expect to see? Something that looks half as tall as it used to.
It's not about math.
Okay.
Like red jewels. What would happen if like there's a red